Okay. Graphs of functions, part 1. F of x equal minus 3x power 4 plus 4x to the power 3. We have to find the critical points, all the intervals of f where f of x is increasing and the intervals where f of x is decreasing. Values of f of x are decreasing, and we have to deduce those critical points where we have a local maximum, local minimum, or saddle point. Let's start. First, we find the derivative f prime of x equals 0 to find the table of variation, and at the table of variation we can see all the results, right? We take derivative equals 0. This means that, right? This means that negative 12x cubed plus 12x squared equal 0. We factorize minus 12x squared into x minus 1 equals 0. Taking each factor equals 0 gives us negative 12x squared equals 0 is 1. X equals 0. If we have to find y, substitute x equals 0 in the original function, we get 0, so we have a point 0, 0, and x or x minus 1 equal to 0, 1, x equals 1. Also, we can substitute instead of x equal 1 in the original function, we get minus 3 times 1, which is minus 3 plus 4, that is 1. So we have 1, 1 as y value. Now, what we do is we draw the table of variation. Okay, we have x from minus infinity to plus infinity. We have two critical points here, two critical points, which are 0 is a critical point and 1 is a critical point, because 0, 1 makes the derivative equal 0. Let's first find variations of this derivative. Okay, the first factor was negative 12x squared, right? It's equal to 0 when x equals 0. Okay, here x squared, here we have to be careful, right? Because x squared is always a positive or equal to 0. But multiply it with minus gives us always negative or equal to 0. So negative all the way. And the other factor was x minus 1, which is 0 for x equal 1. And what are the coefficients of x? What is the coefficient of x? Coefficient of x is 1, which is positive. Same sign of this positive coefficient to the right of 0, different signs to the left. This is how can we can make it in a faster way. Otherwise, we have to discuss, like if x minus 1 positive, this means when x greater than 1. X minus 1 negative, this means when x less than 1. So when x greater than 1, when x more than 1, from 1 and above, its positive value takes the positive value, and when x less than 1 takes the negative value, right? When x less than 1 takes the negative value. We can directly say same as the coefficient, same sign as the coefficient of a, if it is one factor for sure, to the right of 0, and different signs to the left. Now, the product of these two factors gives me the derivative, right? The derivative was negative 12x squared into x minus 1, which gives me negative 12x cubed positive 12x squared. And that's, we multiply the signs, minus times minus is plus, minus times minus is plus, and minus times plus is minus. Here we have 0, here we have 0 for f prime of x. Now, f of x. When x equals 0, we just found y equals 0, and when x equals 1, we found that y equals 1. What's the meaning of positive sign here in the derivative? This means the function is strictly increasing function. So the values of f of x are the values of r of x. We can find it here are increasing if f prime of x is positive or equal to 0. So it's also sorry, also here positive, positive. Here we have negative sign. This means the values are negative of the derivative, and f of x in this case will be decreasing. So what do we have here? We have, as you can see, we have critical point 0. What do we call it? It goes up, increasing up to 0, passing by 0, and then continues as decreasing, passing by the point 0, 0, and continues as increasing. So it increases, and then it increases all the way. So this we call it a saddle point, right? It's a saddle point. And what do we call this point here, which is 1 abscissa 1 ordinate? F prime of x at this point 1, 1 changes its sign. It's not like the saddle point, positive, positive. It was positive below 1, now it's negative. So it was increasing, now it goes like decreasing. This means we call it here a local maximum point. Local maximum point. And that's it for this example. Let's do another example. Let's do another example. I don't know if we still have time for another example. We will try and we continue in another video if we don't have time. So let's do a function g of x now. Function g of x is equal to radical x into 1 minus x. X into 1 minus x. It's a irrational function, right? It's an irrational function. First, this is not a polynomial, right? This is not a polynomial. It's a radical function. So first we should find where is this function, where this function is defined. So let's see. X into 1 minus x, we need them to be greater or equal to 0. What's that mean? Okay, we can draw a table or a number line from minus infinity to plus infinity. We have two different factors. X is one of the factors, right? X is one of the factors, and 1 minus x is another factor. But we need just to have where the function is greater, where the radicand inside the radical of the function is greater or equal to 0. So the first x is equal to 0 when x equals 0, right? When x equals 0. And 1 minus x is equal to 0 if x equals 1. If x equals 1. Alright? So x equals 0 when x equals 0. 1 minus x equals to 0. Take x to the other side. So when x equals to 1. These two values. Now, what is the coefficient of x here? It's positive, so same sign to the right of 0, opposite to the left. What is the coefficient of x in the other factor? It's minus. Same sign as the coefficient, opposite to the left. What is the final product of these two factors, which is x into 1 minus x? Final product of these two factors is negative here, positive here, negative here, 0, 0, right? So we need this function to be greater or equal to 0, means positive and equal to 0. So we have it here in between these two numbers, these two values, 0, 1. So the domain of the function g is when x belongs to 0, 1, closed intervals at 0 and 1. Why closed interval? Closed intervals because x can be equal to 0 and x can be equal to 1. And why is that? Because we want it greater or equal to 0. If x equal to 0 makes all the radicand equal to 0, and this is available. It shouldn't be negative. And see you, we continue in the part 2.